Good morning, ladies and gentlemen. In recent days, you would have seen that 3D printing as a form of rapid construction technology has picked up a lot of imagination and a lot of traction. Now, in the course of next 10-20 minutes, we will try to understand the basic elements of 3D printing, how it is currently being used, although in nascent stages, how it is being used abroad, and how best we in India can build upon the traction that has already been gained. So, attending the session with me, to my right, is Professor Manish, professor from IIT Gandhinagar of Civil Engineering, who has been taking a keen interest in such technologies, especially in 3D printing, and he has been mentoring students. And to my left is Sri Shashank. Mr. Shashank is the IIT Gandhinagar sponsored or IIT Gandhinagar guided startup, MyCarb. He belongs to that startup, he hates that startup. It's a teamwork, to be precise. However, he is the primus inter pares who is trying to run the show. Now, in addition, from IIT Guwahati, we have requested the presence of Dr. Panda, a professor who has again been taking keen interest in 3D printing. Having said so much, let us move on. Professor Manish, sir, we have got so many technologies like MyVon technology. If I understand, a technology where shuttering is already provided in situ and you try to force feed concrete, and that concrete spreads into all the crevasses and fills it in form, and then it takes the shape of a building, and the moment it is set, the same shuttering material can be used repeatedly for a number of times. And that is one particular technology that has caught the fancy of Indian construction industry in times nearby. However, today we are talking about 3D technology as a new technology that is catching the imagination of many. Could you say as to why you feel 3D technology is the rising star in rapid construction?
Thank you very much, Brigadier Muthukumar. And it is my pleasure to be here, and very good morning to the audience. And 3D concrete printing technology, let me just tell about the basics of how it works. So basically we have a 3D printing setup that can be robotic, that can be gantry based, and we pass a cementitious material through that system, and that basically produces the material layer by layer in a way that it gains sufficient strength immediately after being printed, and it is able to support the layers that are being printed above it. Now the process basically is attractive because it is automated and it is very fast. Here, if we look at it from the point of view of defense facilities, not just the overall construction scenario in the country, time is of utmost essence, and our construction, whether it is civil or whether it is defense, it gets affected significantly by factors that are sometimes in our control, sometimes not in our control. For example, if there is a natural calamity, we will not be able to complete our production on time thanks to the manpower issues, thanks to the supply issues. The world is undergoing substantial changes at this point as we speak, and the economy and many other factors, they impact our overall ability to be able to construct things in time, while at the same time India is needing a lot of houses, as also has been highlighted by the government of India and many state governments time to time. So basically many of the lacuna that we come across in the conventional construction, that can potentially be mitigated by 3D concrete printing technology. This technology can be used to produce small pieces which can be joined together to make small houses. Those small pieces can be printed in the form of furniture. Those small pieces or somewhat larger pieces can actually be used as consumable or reusable formworks that will save a lot of time that actually goes into the erection of formwork. That technology is still emerging, and technology can actually help us get to a level where we can construct large buildings as well in one go in barely few hours. We are also looking at it from the point of view of climate. Here we are also looking at it from the point of view of aesthetics. Because it is automated, because it is machine control, it is very easy to come up with shapes that are very efficient in not just resisting loads of different kinds, including that often the defense structures are concerned with, but also this can be very useful in mitigating some of the climate aspects, for example by reducing the amount of energy that is required to keep a certain temperature level within a house or within a facility made out of 3D concrete printing. Another very interesting aspect is that this technology is inherently, at least till date, it has been incompatible with conventional reinforcement, conventional steel reinforcement, and those who are involved in construction and maintenance of structures, they know that in recent years the problem of durability has arisen in such structure on account of usage of the steel reinforcement, and these reinforcements basically get corroded over the years and damage the structure. The current 3D printing technology scenario that basically forces the research, basically the academia and the industry to work together and come up with technologies other than the reinforcement, the steel reinforcement, in order to make up for the tensile stresses in the 3D concrete printed structures. And that basically implies that there is a lot of potential for the structure to remain pretty much undamaged on account of the durability aspects for many decades. So that again will have implication on the climate scenario that we are having today. So there are multiple fronts which make the 3D concrete printing technology attractive, and the circumstances today are such that it is gaining a lot of traction, as you rightly said, and attention, and there is a potential that it will grow further and it will help solve many of country's problems. Thank you.
Thank you very much. Professor, it was a real eye-opener to listen to you. And ladies and gentlemen, the important part is where the professor tells us that it lends itself to a futuristic thought process of a happy marriage of convenience between the academia and the industry, wherein we can look at how to use 3D printing for making buildings without steel reinforcement per se, so that it can actually have a much longer life and avoid all the pitfalls that a steel reinforcement brings in. And the other part the professor touched upon is about the world situation as obtaining today. I fully agree with you, Professor, because today construction technology is hampered by gestation periods. You are finding that projects are taking years and years and years and years to complete. So it may so happen that we cannot probably have a hold of exactly as to when the delivery is going to be. So time has become critical because you need a particular project to come up, the infrastructure to even run the project has to come up side by side. If not for the main project, the 3D printing as it is obtaining today can help you to make the infrastructure for the office staff, for the monitoring stuff, for a major project within no time. So we will move into it a little bit. Going on to Mr. Shashank. Welcome.
No, sir.
Mr. Shashank, you are one of the bright sparks who is leading this startup. So wanted to ask you three small questions. I want a few brief answers so that we build up in what direction we are looking to go. So, Mr. Shashank, generally you do 3D printing using a printer. So can you throw light onto how big, how small can the printer be? What generally might be the cost of the printer? Whether the printer is Swadeshi or Videshi, whether you are making your own or you can make your own. Can you throw some light?
First of all, thank you, Brigadier, for inviting me.
Yeah.
It's a pleasure to be here. and I'll just quickly move to the answers to your question. I'll present it also in the screen as well.
Yeah.
So basically, printers can be used for making very small structures, which can be maybe somewhere around 10 kg to 15 kgs as well. And printers can be used for making very large structures, which can weigh up to even 40 tons as well. Let's say, for example, what we are doing with Indian Army as well. So for making the bunkers, PDs, we actually are creating very small structures which can be rapidly constructed at very tough locations, so
Okay.
which can be like man portable as well.
Okay.
And when we are talking about large structures, so we can actually create very large structures which are similar to culverts as well,
Okay.
where we can actually create panels which are having dimensions of 3 to 4 meters in one
Okay.
span as well.
Okay.
So that can weigh up to 40 tons as well. So
Okay.
we have a wide now flexibility with this technology. Printers can span somewhere between like 1 meter by 1 meter by 1 meter in printing space to 15 meter by 10 meter by 6 meter in span as well, which is the state of the art today. There are some companies like Black Buffalo 3D who have developed printers which can build like 4-story buildings in a single go as well. And then coming to the cost of the printers, so if let's say what we have done, we have developed indigenous systems. So right now for us, the cost of printers somewhere ranges between 50 lakhs to 80 lakhs somewhere, and whereas if we are going to buy these printer from some European countries, so that would range somewhere between 4 crore plus. So definitely indigenization of this technology helps in controlling the capital investment. Also because there is a lot of research going on in terms of material in India, so that also helps to reduce the cost of material. That is why even Indian market is now actually ready to accept this technology for the construction segment as well.
Excellent. So, Professor Manish, I have a query again to make to you. I am hearing from people that they use proprietary technology for making the material which is going into the 3D concrete printing. Let us say the material for normal 3D concrete printing as it obtains today. Do you subscribe to this philosophy of a proprietary mix? Like a startup called Mica will come up with one proprietary mix and another startup will come up with another proprietary mix. And in this accountability world of today, don't you feel that it should be clearly M25 or M20 and FCK so much and compressive strength so much? And so do you not feel that it should be a very discernible, clear, revealable mix which can be taken to a lab, tested, certified, attached and proceeded with without some kind of a secrecy getting attached to the proprietary mix part? Your view, please.
Thank you very much. So, there are multiple aspects of it. Firstly, if we want to innovate, if we want to come up with new technology, new material, optimal usage of material, we need to provide the incentive to the innovators, and that is very important, and that is a practice that is being adopted worldwide. So there is a rationale behind it, and people follow it. When it comes to the broad parameters that you mentioned, for example the characteristic strength of concrete, the fresh state properties of concrete, some of them I think these are revealed by the even those companies which want to hold some sort of proprietorship, and that I believe again from the point of view of transparency, that's an important step, so that the people, they get to know that how does the strength of the product that they are getting, it compares with their conventional construction. And the most important part here, because this is an evolving technology and we are making buildings, we need to recall that the conventional reinforced concrete construction, it took decades before it could be formalized, and using the formula given in the design standards, one can now construct these buildings. Now here you are coming up with new shapes, methods of optimization on the front of material, on the front of shape, on the front of size and so on. Here testing is very important. So when we are putting the structure, the usage by common people, it is important that these get tested through variety of means. Some part of that testing in the, for example, in the loading process itself. For example, if you make something and if you have to move it, if it is able to lift its self weight, that itself is a test of strength in a way. However, we need to come up with more innovative ways and more standard ways of testing the pieces and the structures that we are constructing at the moment. To me, that's a much bigger problem or much bigger challenge to look forward to rather than the mixes. So same mix, for example, you mentioned M25, same mix can be produced by a number of ways and there is a standard way, for example, given in the code also. Even that can possibly be used. But in order to pass it through the printing apparatus, you need to innovate a little bit, and that is not trivial. That requires a little bit of research, and the companies that are there, they do their own research, and they need to recover the cost, and they need to build their base so that they can continue to innovate on that front. So I hope that clarifies some of it.
Firstly, Professor, what I like, and I would like to be always associated with you in more panel discussions, is because you did not circumvent the question. You actually went, like a good professor would always do, you went on to both sides of the spectrum. On one side, you said that there is a little bit of a liberty to be given for innovation. Otherwise, why will a person innovate? Why will he invest? And second, you also said that it is public use, so it has to be tested elaborately. So that answers me. To me, it answers. But then I would further want to ask you one more question to just take it to a logical conclusion. My question is that even then, so I have at least had the liberty of interacting with a few startups. Each one says that he has a proprietary mix. To my mind, what it appears is that he doesn't want, let us call it like an ink that comes out of the nozzle in the 3D printing. He doesn't want it to dry up. He wants it to have malleability, ductability, and the kind of usability, functionality that it should reach till the time it should reach. And it shouldn't give a half-baked cast. So my point is that are we really having Edisons and Einsteins in every startup who will innovate a proprietary mix in every startup? Or there could be a case in point that it could be a standardized one.
As far as I see, I also made the comparison with the conventional reinforced concrete construction. I imagine in those days, I don't know how the market was, but in those days they must have, in the beginning, whosoever company is able to do something first, they would want to make use of it either through purely commercial interests and or through, in order to keep them ahead of the rest of the market. So here also I see the possibility of having multiple mixes that are actually there in the market, like you rightly said, and those mixes eventually will compete, and the better ones, the more economic ones, the more effective ones will prevail. And in some years we will see what we are trying to protect will give away liberally, that here is our mix, make use of it. There is a possibility that we will do it. But currently, as of now, the way world is looking at this technology, in fact, we had requests from outside India in order to actually give them the know-how of the mix. From different country, people approached us simply because they are paying a huge sum of money to the original manufacturer of or original developer of this technology. So in the years to come, I think this question hopefully will be settled down. And let me tell you, there are much bigger questions to look at. For example, like I said, that how do you handle the tensile stresses in the building? And that is going to require much more innovation. And as we know more, as the frontiers of technology change, the previous technologies are going to be more available to the people. Look at the GPS. In some countries it was available much before when we got to use it. Now it is for free. You see, and similarly, this technology also eventually is going to be available.
Doctor, at the cost of coming in between, I'm very thankful because you have been able to answer my little query pretty sufficiently. Now moving ahead, gentlemen, in a panel discussion, it's also a must to know that we are always not looking for the end of every point. We are sparking a discussion and we continue to discuss and we continue to evolve. And like you said, you have already given the way forward. And how probably you assume the way forward is going to be. Many thanks. Coming to you, Shashank. Now the query is that about tensile stresses, the professor touched. So you are making blocks, modules of 3D, and those modules get collected together at the site. So when you make a module, so you will first design a building, feed the design into the AutoCAD or some kind of a software, feed it onto the printer reads it, and then the printer prints it. And when the printer prints it, you get the shape. That shape you have digitally divided into a number of pieces, marked them, and then move those pieces to the site, either off site or on site, and join them. Am I right? Can you throw a bit more light on the process of 3D printing? How it happens?
Okay.
Yeah.
Brigadier, first of all, we start with the architectural layout, like what actually the client wants. So, what we generally say is you think, we print. So, once we know what is required from the client end, then what we do is we create a 3D model of the structure. Then we factor into account few parameters. Let's say when we are doing it in a factory constructed mode, then what we do, we factor in the what is the availability of the cranes at site, what is the logistic things that we have to account for. So based on that consideration, and what is the limitation of the existing printing facility that we have. So combining these things, we then come up with a maximum size of the panels that we can construct for the structure. And then further we move on to the load part, like when we are constructing, like what is the loads that we have to consider, what is the earthquake zone that we have to consider, what is the wind factor that we have to count for. So after that we come up to the panel level design. So after factoring in all the loads, once we know all the loads, once we know what are the constraints in terms of printing, in terms of logistics, then we do the simulations based on like what would be the stresses coming onto the panels. So this could be a way in a conventional design as well, where we can just create the formwork, outer formwork using this technology, and then design it as a regular RCC, or we can actually do the further finite element simulation of the panels itself, where we know that even the panels are load bearing. So we can do both ways, and then we can design what the panel level detailing would be, and then the printing of that goes into. Once we have the panel level detailing, then we slice the 3D model into 2D layers, and all those 2D layers then are printed layer by layer. All the what is the strength requirement of the concrete that needs to be there, like whether we have to construct a M25 grade concrete for printing, or we have to do a M40 grade concrete for printing. Like for bunkers we do like M35 grade concrete, whereas for shelters and habitats we do M30 grade concrete. So those things are also factored in, and then we also have to account for the joint connection details as well, because this is when we are doing prefab 3D printing, it's mostly done in parts, so the joint detailing also needs to be there. And based on considering all those factors, then the lifting arrangement of the panels has also to be accounted for, because when we are lifting something and transporting, so those load also needs to be accounted for. And then finally the site erection, the waterproofing, the sealing, all those things take place at site.
Very, very nicely brought out. So, Mr. Shashank, when you are lifting a panel, it may not so happen that you are going to give separate handles for lifting. So, is it that you use, if at all you use some reinforcement, is it that you turn the same reinforcement and convert it into some kind of handle to lift?
So there can be multiple ways, like we can provide some metal sleeves which can pass through the structure, which can be later filled, and based on like what is the center of the gravity of the structure, so we design the lifting anchors accordingly. Lifting anchors can be kind of clubbed with the existing reinforcement. Normally what we do, we actually keep the lifting anchors separate, and like there can be some cases where we also have just the sleeves, and the sleeves are surrounded by certain reinforcement to actually distribute the stresses as well.
Gentlemen, what he is trying to say is that occasionally you can have some cleat kind of an arrangement where forklift puts in its jaws and then lifts. There can be even a crevasse.
Yeah.
Or you can have even a same reinforcement combined into a lifting anchor kind of an arrangement.
Kind of.
So he is looking at a 3G gravity kind of calculation, and then he is working at it. So good. So now we are joined by eminent Professor Panda from IIT Guwahati. Dr. Panda, welcome to you. Are you able to hear us? Dr. Panda, a query to you, sir. Thanks for joining in.
Yeah.
Is that now we are talking about this 3D printing.
Yes.
So, you know, it does away with the traditional framing, forming and block works, etc.
Okay.
So, what happens is that one of the major advantages is that even a kind of a unique kind of a shape for which an architect would have gone for thousands of supports to
Yes.
make it into a conventional structure, whereas here you are able to print it in a hermetically sealed environment in a lab or in a construction off-site construction facility, and simply bring it at that site and erect it, or do an on-site thing, because accuracy is possible, all kind of turns and crosses and creases are possible. But then the point is, do you really feel that a 3D technology will also lead to what the leftists would call as the conventional labor getting shut out of the construction industry?
Yeah, it's a good question. My perspective in this regard would be like, for example, everywhere when you start the new technology, people always come with such kind of questions. Like today, like when we had our computers, so people keep on arguing that one day computers will take away our jobs. But if you see today's scenario, it is not happening. Rather, computers are creating more jobs. Okay, so I also feel in a similar manner that our construction workers are doing very cheap type works. If you can upgrade our technology to a digital platform, they can do a better job in this regard, and we can provide them more training for operating the machine, for operating the mixed design planning, and also they can have a training to operate the complete thing from a digital platform. So I think if I see from a digital media perspective, there are a lot of opportunity that we can provide them even higher number of jobs count compared to that what people have a feeling that when we are dealing with concrete printing, it is true that in many publications, many medias, they are claiming that we can do the job with less number of workers. It is true, being part of digital technology, it is true, but in the same line I feel that in this domain there are more training we can provide to the construction workers, and they can do a better job than what they are doing today.
Doctor, actually,
Yes.
I should grant it to you because I started off with a little tougher question. Because
Okay.
I said that I wanted the academia to understand the hardcore industry concerns as well. That has been very well addressed by you, and many thanks. Now, the query that I have is that when you were away, we had a small little question about the futuristic role of 3D printing, where we say that 3D printing can
Yes.
also lend itself to evolve into a printing technology without using really the steel for reinforcement, and probably look at some alternates so that the longevity or the kind of durability for long number of years without the ill effects of steel getting corroded over time, etc., can be avoided. Your call, please.
Okay. Yeah. So this is a very important questions in concrete printing. People talk about reinforcement, and see, again, my concern in this regard will be if you look back to the structures that were created by our ancients. Like if you see some structures that were not fully reinforcement, if you see the temples we have, if you see some ancient structures, they were not reinforced the way today we are making our homes. So I feel that if we can properly design the material, and the unique things in concrete printing that I don't know why people are taking it in a different way, that we can create some structures that do not need any kind of reinforcement. There's a concept in academic like there is self-reinforcing designs. So being a part of concrete printing, when we are getting a freedom to design such kind of structures, I think we should first try this kind of structures that are going to be self-reinforced. There are some designs which is already earthquake prone kind of things, which is going to save from such kind of disasters. I think before we talk about adding reinforcement to our concrete structures, we should explore those designs platforms by our architects that can be done easily with our 3D printers without or with very minimum uses of reinforcement. So that is one aspect. Coming to the traditional way of making concrete, I think still we are discussing in the major platform that how we can add reinforcement during printing or after printing. There are some examples in other university have done that after printing they have added the reinforcement. So looking into this kind of strategy to reinforce the 3D concrete, what I would say that it is still possible to take an hybrid approach. We are not simply deleting the conventional construction strategy from our work, so we can take a hybrid approach. I think many university and companies from other countries, they are trying to take a hybrid approach so that to make it more structural stable. And here one more question will come that regarding codes and standards. You know that construction industry is very much dependent upon the codes regulations. Without proper authority, I mean, though we can print some structures, people still have this kind of doubt in the mind, can I use these kind of structures for my end applications? So sooner or later we have to try to find some kind of codes or standards or regulations that will make sure the way we are creating the structures by 3D is going to be safe and durable. So these are the 3 to 4 different aspects we have to look into it while we are dealing with concrete printing. First will be like you try to bring in help of architect. We can try to design some structures that do not need reinforcement. There are some structure design by the structural architect itself. They are more stable. We do not need reinforcement there. So that kind of approach we can adapt. And secondary, like if we were trying to make something which is more traditional way, we can take a hybrid approach, which is a combination of 3D printing and post reinforcement. So these are my take on this topic. Thank you.
Professor, again it was a good interaction where you could immediately grasp what we wanted and you could help us with AIM Plus, wherein you spoke about the hybrid approach. Many thanks. Professor Manish, one more question to you is that nowadays occasionally we look at load bearing modules and some non-load bearing modules. Many of them are load bearing modules as I find them, with some kind of cavities in between, where integrally while printing they have some sparse reinforcement, and at site they add some more reinforcement if necessary, and they fill those cavities inside with concrete and admixture, and then they keep moving ahead. So now willy-nilly that will come to that hybrid approach which you was talking about. But then do you find that there is a need to go in for load bearing, stroke, non-load bearing, stroke, some kind of a patented type of a construction, or you feel that it should be as the structure evolves?
So, first of all, the approach that works in small scale buildings, that may or may not be immediately applicable as you try to expand in terms of size and in terms of the architectural aspects. So as we are growing further as a civilization, we are coming across the loads that our structures have never seen before. For example, today if there is an important structure, you do not just design it for the earthquake, you do not just design it for wind, dead load, live load, you also consider the sufficient amount of the blast loads that can come on account of intentional or unintentional activities. So in these situations, in extreme loading situations, often it is more economic to make use of the non-linear deformability of the structure, and which is why I feel that more innovation will actually be needed as we expand in the size, in the scope, and what you mentioned, that officially, that obviously is a very prudent way of doing it. In fact, we have done it ourselves in collaboration with the Indian Army. But the question is that optimal? Can we do it at a larger scale? Will it be economic? So these questions still remain, and we need to find the answers to these questions.
Thank you, Professor. Mr. Shashank, a small query. What do you think when you are constructing modules and you are taking the modules, let us say on off-site you are constructing, taking them for assembly on-site, you have to join module after module after module. So how do you exactly align the reinforcement, add reinforcement, lap the reinforcement, or have some pace between first module and the second module so that it adheres to each other? Can you throw some light?
So like when we are constructing or printing the structure, so there are two ways we are putting reinforcement. One way is that we actually are putting reinforcement during printing itself. We have like cut and bend steel, which is cut and bent as per the design precisely. So, and when then that's done, we actually do place it as per the structural requirement, as per the structural design spacing. And so that is one way that we can actually place the cut and bend rebar during printing itself. And then the second approach definitely is like the post tensioning of the structures, of the bridges, like where we leave the conduits which are designed specifically, and those are printed very precisely within an accuracy of like 2 to 3 mm, and within those conduits then we can pass the reinforcement. So if there is a requirement of post tensioning, then the steel tendons can pass through those precise structures, or we can have like larger cavities where the steel cage for, let's say, column or beam can also be placed precisely. And in those cases the printed concrete would act as kind of a, I would say, basically a cover, concrete cover.
So, Mr. Shashank, don't you feel that there will be a little difference, that there is a cavity there is a proprietary mix you use in the lab or in your site facility, off-site facility. You printed the module, brought it to the site, you aligned it, correctly placed it, so the reinforcements pass through, cavities meet cavities, and then if need be, you've passed some more reinforcement and lapped it. But my point is that those cavities are now going to be filled with some other concrete and admixture. Now, what will be the mix match and the compatibility between the concrete that emerged out of your lab and the concrete which you are trying to fill for this reinforcement?
Fine. So definitely in this, what we have actually accounted for is to study the behavior of the printed concrete and the concrete which is cast in situ are similar. So basically, if let's say we are going to study the concrete, the behavior of a composite system where we have a printed concrete which is working basically as a just formwork, and then we have steel rebars, then we are pouring cast in situ concrete. So one way to look at it is like, because we are using the printed concrete just as a kind of a covering, and when we actually design the structures, all the covers, the concrete which is outside the steel rebar is not considered into the design. So for designing of your structures, you can consider like the steel rebars and the concrete which is poured in as a unit monolithic structure, and that actually would be taking up your structural loads. So that is one way of looking it, like when we are doing a composite structure, that is consider the outer printed concrete just as a formwork, which is kind of a formwork which is consumed during the construction itself, and which is not accounting for the structural load bearing part. So that's one way to look at when we are dealing with a structure where we are pouring concrete. And another way is if we are actually using a printed concrete which is done in such a way where we are just leaving cavities for post tensioning, then we have the entire structure made using the printed concrete itself. So we have one uniform structure where we have printed concrete, and then the tendons are passing through where we are also accounting for the post stressing load.
Thank you very much. Shashank, firstly, I was probably putting you into a bit of a zone of an experiment, which you took on well and you answered. Now, the point is, however, you gentlemen and ladies will be understanding that old concrete, when it makes new concrete, or one type of concrete, when it makes another type of concrete, we use some admixtures, we use some methodologies to ensure that there is a bonding. So, probably we will have to use that here also, despite calling the outer portion as a cover or inner portion as the structural part, though with a pinch of salt I will say that that is the correct interpretation to probably do a design in a caged concrete, caged reinforcement type of a situation. But otherwise, generally, I would say that care and due diligence would need to be taken to ensure that the two types of concrete marry and they behave as one. Dr. Panda, your view please.
Yeah, I think it's a right point to mention here that when we are dealing with this kind of old concrete and a new concrete, the proper adhesion between this is very important. In fact, itself, if you think about the concrete printing, there is a bigger issue like we address in most of the journal papers, that interlayer bond strength. So when we are printing that, suppose you have a big structure and you are printing it layer by layer, and even if you are allowing more time gap between two layers, you still get a cold joint kind of scenario in between the two layers. The same thing can be seen here when you have printed the concrete as a formwork and then you are pouring another concrete. So the bonding between these two is a critical importance where we have to make sure they are acting like a monolithic component. So in this regard, I think already some traditional work has already been done. When we see like what is the effect of adding old concrete to new concrete. So similar approaches can be taken easily to make sure that whenever you are adding or pouring a new concrete, it must properly adhere to the old concrete. And one important aspect about 3D printing, since we are printing the layers, many often we have seen that layers are not smooth enough. They have a pattern kind of surfaces. So that is also going to provide a more strong support for adhering the concrete you are pouring inside it. And this is only for structural. At IIT Guwahati, what we are looking into this topic, we are trying to put some kind of thermal insulation materials in between these two walls of the 3D printed panels, so that not only structural but also other functional properties are also going to be attained by the same structure. Normally, when we print some structures, we have an attitude to make it more structurally stable. But apart from that, we can also look into multifunctionality of the concrete wall, because we are printing it, so we have full control to do whatever changes we need for our comfort. Why we should look always from a structural point of view? It is important that the wall should be, or the building, whatever structure you are printing, it should be structurally stable from the initial point of view. But sooner or later, as we are printing, we have all the freedom to incorporate some kind of functional material, some kind of thermal insulation material in between these two walls, so that also we are going to get some thermal compact in addition to the building, which is just acting as a structural element. So in this regard, I think there are a few challenges. We have to look into it, proper bonding between old and new concrete, and even if you are adding some kind of steel cable to make it post tensioning, that how it is adhering to the both the side of the plate. These some issues are still there, but I think issues has already been addressed in some publications. It needs serious attention if we want to make the 3D printing successful in the commercial market.
Dr. Panda, my heart goes out to see a vibration, to see a resonance to the real concerns being addressed from this place, because I find that you are able to empathize exactly with the thought process that I was trying to evoke. Very, very nice of you, because my feeling is that howsoever amazing this technology could be, there is a ground to be covered, and it's a work in process, which you will appreciate. But definitely that process is going good. Just the point is that here you are having a concrete being laid using a nozzle based on a design which has been electronically fed, layer by layer, hardening time, functionality, durability, because there is no vibration and there is no real time conventional concrete setting process. So we need to have excellent quality control at the printing facility. So let us say there is a project protagonist who has ordered the project, there is an agency which is executing the project, somewhere let us say off-site, to take a case in sample, the structures are being printed, because when the structures are coming to the site, by going from what Mr. Shashank had told us, occasionally it could be only the cover coming with minimal reinforcement. Now, whether it is going to have enough shear and enough tensile compatibility is a point, but then the point is that it should reach safely.
Correct.
The quality control should be perfect. So, Mr. Shashank, how do you ensure abject quality control in the off-site printing facility?
So there are two parameters. So one parameter would be related to the dry materials. So like what is the dry materials which are coming into the concrete. So that is like cement, sand, then admixtures, fibers, whatever you are keeping as the dry mix. So we have to ensure that and then the ratio of these dry mix. So there has to be a very good quality control and checking of the cement, sand, fly ash and all the admixtures that are coming in. So that first of all we do take care through the like regular checking, whether we are getting the correct sieve size of the fly ash, correct sieve sizes of the sand and correct strength of the cement that we are getting. And then comes the ratio. So we have to ensure that whatever the ratio that we are actually creating the concrete for, let's say M30 and 35, then the ratio has to be perfect. For that we have an automated system where in the batching plant itself we actually put in the right proportion of each and every constituent, and then there has to be another process of like duration of dry mixing. So that has to be again automated and controlled, that it should not change over a period of time. So if it is a, let's say 3 minutes of dry mixing or 5 minutes, that has to be consistent. And after the dry mix is prepared, then comes the what is the water to mix ratio, water to cement or water to mix ratio. So there what we have done in our facility is that we have an automated system where we know what is the ratio of water, and there is a flow meter which controls the water feed and when there is a dry mix feed. So the ratio is always maintained. And if let's say we are actually printing, if we are actually using a higher quantity of water which would actually reduce the strength, then the material would become very flowable, so it won't print. And if we are using let's say very limited quantity or less quantity of water, then what would happen? The wet concrete would be very stiff. So you can see the cracked layers when it is being printed. So this is how it's, I would say, a process where automatically there would be an inherent quality compliance, but again, this has to be at the factory level where you are printing. And then just not printing, then we have to ensure that there is
Transportation.
I'll come to transportation. Apart from printing, we have to ensure that the water loss is not there, because we are creating a structure which is not having any formwork or shuttering, because in normal conventional construction we have shuttering which reduces the moisture loss in the initial stages. So we have to ensure that the moisture loss is not there, otherwise there would be surface cracking which would lead to deterioration. Now coming to the transportation part as well. So we have to understand like what are the stresses which are coming up during the transportation, during the handling of the panels, and we have to assess like what is the 1 day strength, what is the 3 day strength, what is the 7 day strength, and how much stresses are going to be there when we are transporting or erecting. And based on the strength, based on the test that we do, like let's say after 3 days it is achieving let's say 45% of the strength, and that is something where we are having let's say at least 2 times the margin of the stresses which is coming due to the erection and transportation, then that would be the time frame. So for the transportation part, it is very important to understand what is the strength evolution of the printed concrete and the structure itself.
Very nice. Now the point is, Dr. Panda, coming over to you, you will be understanding what I said, and definitely there was an attempt from Mr. Shashank to answer the same. Don't you feel that there is a case in point to weave into the contract documents that the printing process, if not the proprietary formula, the printing process and the testing processes have to be recorded and kept for posterity? Mr. Panda.
Yeah, I think this is very important aspect when we are going from lab to applications. The quality are very important. So what we do here, first of all, I'll just tell 2-3 strategy that we are adopting in our lab. So definitely, as Shashank mentioned, like during printing, one material compositions have to be uniform throughout your structure, because if we are printing a material today and tomorrow it's becoming different, then it's very difficult to control the entire property of the structure we are making. So in this regard, first an automatic mixer, I think what he already mentioned, it is of prime importance. And second thing, what we are now developing, that during printing, we are trying to integrate some kind of sensors at the nozzle itself, so that it is going to track the material viscosity and other things, so that we will ensure that when we are printing different layers, all the layers are of having uniform properties. So we are connecting those things to a database, and based on some artificial intelligence feedback, we are always tracking all these changes. As you mentioned, there is a need to have a database regarding all the experiment you are conducting for making this concrete printing viable for applications. So starting from printing, testing, and till you deploy the structure for a final applications, we try to record all the database, because later with the help of machine learning or AI, we can make a better design. And that's why I told you in the very beginning that people think that in concrete printing, we are having a shortage of laborers. No, like we are going to have a bad effect on the employment side. It is not true, because just now we discussed about AI, machine learning, improvement, tracking with Industry 4.0. There are so many opportunities we can create in this kind of job environment that is going to be helpful not only to the people who are working in this topic, but also it is going to ensure that whenever you are using a concrete printed structure, it is most stable, durable, and properly quality controlled. Without quality control, definitely it's not going to be as successful in long run. So therefore, at every stage, whatever testing we are adopting, we must have to keep a record like checklist, so that tomorrow when we are deploying the structure for any end user applications, we must ensure that we have fulfilled the minimum targets. And through the database also, nowadays these are machine learning age, so we can connect it with machine learning, and based on the feedback or based on the suggestions, we can further do a better design and slowly keep on improving the process, to make sure that next time when you design the mixer, or next time when you print the material for a structure, it is further going to be completely out of any error. So that is the way we are looking into this problem for quality controlling in concrete printing.
Doctor, many thanks for your answer. Just a query, one more. What do you think about a load bearing module and a non load bearing module in 3D printing? A quick contribution, please.
Okay, so normally what I have seen when we are talking about load bearing structures, so far hybrid approaches are being taken. Most of the examples, if you see, they are only printing the formwork and then pouring the concrete to make it structurally more stable. But if you are just simply talking about those walls that are not taking any kind of loads in your buildings, then I think those companies who are printing lightweight designs that are more preferable in this regard, because you are not only saving the concrete material but also your productivity is also going to be improved. So depending upon the type of loading, it is the best way to design the panels, because in 3D printing we have the freedom of designing the structures. Why every time I will follow a same pattern of design based on the loading applications, based on the requirements, I will be keep playing with the designs optimum it, so that materials will be saved. I can do the job in a much faster rate than others are doing, and also at the same time with proper quality control, I will ensure that the structure is most stable and reliable for further uses. So there are different scenario, we have to consider it, and accordingly the design should be made. That will be my suggestion.
Thank you. Doctor, it was really a pleasure interacting with you. We would like to do more sessions with you and you, Shashank, and Mr. Manish. Just before we close the topic, a few points, gentlemen. You are saving on formwork, you are saving on time, you are saving on wastage, you are improving on accuracy, you are improving on typical deliverability of unique and awkward structures, non-standard structures. You are having a great offset and a benefit when you go for multiple printing, economies of scale. You have got the ability to ensure accuracy, quality control at a given place with a small team of people, and you have this technology up and about to help you on immediate paraphernalia for large constructions, to supervise, to overlook, add on, and for housing for the disadvantaged sector in fast time frames, or in the military to come up with structures in the war front in a pretty fast time, to reach inaccessible areas where labor is not available, come up with out of the box solutions. So the avenues are many. 3D printing has laid it open. So ladies and gentlemen, we close this session only to expand more and discuss more about 3D printing in times to come. Thank you.